Hi everyone, this is a part 2, finding length of sides or angles of right triangle using trigonometric function values. So please look at part 1 first if you haven't looked at part 1 yet. Inverse trigonometric ratios. So let's say you have a statement as sine angle A is equal to 1/2. How do you find angle A then? You can use inverse sine. So from here, angle A is equal to inverse sine of 1/2. So you might say, what does inverse sine of 1/2 means? That means you're trying to find the angle A such that sine angle A makes the value of 1/2. So if you think about it, what angle can you take a sine function so that the value becomes 1/2? So you want to be very careful with this style. You always want to think about this special triangle, which means 30 degree, 60 degree, 45 degree. You always want to consider 1, 2, square root 3, 1, square root 2, 1, 2, square root 3, square root 2. If trigonometric ratios consist of those numbers, it's very worthy for you to check. Is that does that have anything to do with 30 degree, 45 degree, 60 degree? So when you look at this ratio of this particular example, 1/2, 1/2. So if you remember this length of side, 1 and 2, we do have 1 and 2 in this special triangle. What does that mean? Sine angle A is 1/2. You want to double check against sine value of special angles. If you look at it, sine 30 degree equal to 1/2. So you should know, angle A is 30 degree. You might say, what if it was 1/3? Well, 1/3, we do not have a 3 as a length of side, meaning that's not special triangle. It has to be specific value. So that's how you get 30 degree. Usually special angles such as 30 degree, 45 degree, 60 degree, your teacher will expect you to get that angle without using calculator. If calculator is allowed, all you have to do is rewrite this statement as this and just type that into the calculator. So inverse sine 1/2, 1 divided by 2, and type it. Inverse sine 1/2, I just typed it, I got the answer as 30 degree. Please make sure your angle mode is in degree when you do that using your calculator. Okay, another example. What if we have statement as cosine angle A is equal to square root of 2/2? Again, square root of 2/2. If you look at it here, 1 and square root of 2, but we don't have 2. So you might say, well, this is not special triangle. So just be careful. Square root of 2/2 is exactly same as 1/square root of 2. How? You can trim this down by divide by square root of 2, divide by square root of 2, numerator, denominator. Square root of 2 divided by square root of 2 is 1. 2 divided by square root of 2 is square root of 2. So think about it. Square root of 2 times square root of 2 becomes 2. So 2 divided by square root of 2 will make a square root of 2. So square root of 2/2, before you rationalize denominator, is actually same as 1/square root of 2. So this is the same statement as cosine angle A is equal to 1/square root of 2. 1/square root of 2? 1 and square root of 2. So you should know, this might have thing to do with the 45 degree. Cosine 45 is square root of 2/2. Cosine 45 square root of 2/2. Square root of 2/2. So you should know angle is 45 degree. Again, if you are allowed to use a calculator, you might just type that into the calculator as it is. Cosine, inverse cosine, square root 2 over 2, then you will get the answer. What if this is the problem? Tangent angle A is equal to square root 3. Well, square root 3 is same as square root 3 over 1. So you're dealing with square root 3 and 1, and if you look at it, special triangle does have square root 3 and 1 in one triangle. So you might say square root 3, if you look at the tangent 60 degree is equal to square root 3. So you should know, angle A should be 60 degree. Again, if you have calculator available, all you have to do is tangent angle A is square root 3, angle A is inverse tangent of square root 3, and you type this statement, inverse tangent square root 3 into the calculator, then you will get 60 degree. Next example, find the measure of the angle A, round to the nearest tenth if necessary. So, there is a right triangle. We gave you length, 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 all the lengths. What are we looking for? Angle A. This is the angle of interest. Angle A, we want to find this. So, you can set up trigonometry. So, ka, toa. In many cases, you will be given only two lengths of sides. And you will have to choose which one you can use among sine, cosine, tangent. Here, all three lengths are provided. What does that mean? You can go with sine, you can go with the cosine, you can go with the tangent. Everything would work. So here's your angle A. Label it. Opposite here, hypotenuse here, adjacent here. Anything is available. What did they do? They used the sine. So you might say, why did they use a sine? Well, because they can. Well, can I use a cosine instead? Yes, you can. Can I use tangent instead? Yes, you can. Well, they use the sine, so I'm going to just follow their explanation. Sine is O over H. Sine angle A is O over H. So you can set up sine angle A is O over H, 9 over 17. So from here, you can apply angle A is equal to inverse sine. I don't like the way they swap this. So from here, I usually write angle A is equal to inverse sine of 9 over 17. 9 and 17, yeah, that's not special triangle for sure. 9 and 17 is not anywhere. So you cannot solve this by using special triangle. You just have to type into the calculator. The inverse sine of 9 over 17. Type into the calculator, you get the answer. That is angle A, which is 32 degree. Next question is asking you to find the angle B. That's exactly the same triangle. So I say in this right triangle, we know this is 90 degree. We just found out this angle A is 32 degree. Why don't you just calculate angle B from 180 minus 90 minus 32? So you can do, I'm trying to solve the next question. We figured it out 32 degree from previous question. They are asking you to find the angle B. You can do all this trigonometric function work to find the angle B, but I'd rather just 180 degree minus 90 degree minus 32 degree to find the angle B, which will be what? 58 degree? That's less work. So we found the angle B for next question. You should try this by yourself. Once you get the angle A, you can use angle A to get the angle B. They are exactly the same question. Okay. word problem, application problem, angle of elevation, angle of depression are used very frequently. So angle of elevation is something when you look up something, always angle from horizontal line to looking up. That angle is considered angle of elevation. Okay, what's the catch? Some students think angle of elevation is from vertical line. So you're looking up something and you're trying to say that's angle of elevation. Be careful, that's gonna be bad. Nobody walks like looking up straight up like that. We just normal eyesight gets forward to the straight forward. So when you look up something, this is angle of elevation. Always from horizontal line to looking up angle. That's angle of elevation. So as long as you be careful with that, always from horizontal line, angle up. That will be angle of elevation. Same logic. When you look down something from high position, that will be angle of depression. Same thing. It has to be measured from horizontal line. You are looking straight forward and looking down. That angle from here to looking down, that angle is angle of depression. Common mistake for students is students try to do angle of depression from vertical line like this. This is angle of depression. That's how you lose the problem. As long as you understand it's always from horizontal line to measure angle of elevation, angle of depression, no big deal. Example 6. From a camera in a blimp, a golfer is standing at a tee looking up the green on a hill. If the tee is 36 feet lower than the green and the angle of elevation from the tee to the hole is 12 degrees, find the horizontal distance. It's a lot easier in this question because they gave you diagram to deal with. Usually they don't give you diagram and you have to figure out diagram by reading the description in words. That's a little more challenging just to figure out the situation in diagram. This one is no big deal. They gave you diagram and everything. This is 12 degree. Angle of interest is right here. That's 12 degree. Find horizontal distance. They are looking for this length, horizontal distance. And they gave you this length. We know this angle. So since this is angle of interest, this is opposite, hypotenuse, adjacent. You have to make a call, sine, cosine, tangent. We know this length. We are looking for this length. So we are dealing with O and A. So, ka, toa. Which trigonometry deals with O and A? It should be tangent. So you say tangent 12 degrees is equal to O over A, 36 over X. Again, setting up equation like this is big part of it. Solving for X. X is on denominator, so you need to bring that up to the numerator. How? We multiply by X both sides. Multiply by X both sides. Or cross multiply. So X cancels out here, becomes X tangent 12 degree is equal to 36. Solving for X, divide by tangent 12 degree, divide by tangent 12 degree. This one cancels out. So X equal to 36 over tangent 12 degree. X equal to 36 over tangent 12 degree. You will have to type that into the calculator. So if you do type into the calculator, you get 169.4 and the unit was yard. That's the answer. Exactly same question. From a blimp, the heel of the roller coaster has an angle of descent or an angle of depression of 60 degrees. Its vertical drop is 195 feet. Find the horizontal distance. Okay, this question again gave you diagram and everything, which is a lot easier for you. Usually they don't give you diagram. You need to read the description in words and figure out this diagram by yourself. So since diagram is provided, angle of depression is 60 degrees. Do you see this angle is measured from the horizontal line? If you take that as 60, that would be a huge mistake. Okay, given this triangle, finding length of x is very similar to the question we dealt with so far. So here's the angle of interest, opposite, hypotenuse, adjacent. We know this length, we want to know this length, ONA, or tangent. So you say tangent 60 degree is equal to O over A, 195 over AX. Angle is 60 degree. What does that have to do with anything? Well, do you remember 60 degree is a special angle. So in many cases, your teacher will want the exact value, 60 degree. So you need to draw this triangle, 60 degree, opposite, adjacent, and you gotta label that accordingly. Figure out what value of tangent 60 degree is. Tangent 60 degree is square root 3. So square root 3 is equal to 195 over x. Solving for x. So multiply by x both sides. X times square root 3 is equal to x times 195 over x. It cancels out. So x square root 3 is equal to 195. Solving for x. So divide by square root 3, divide by square root 3. So x equal to 195 over square root 3. If your teacher says no calculator available, then this is the answer. You will have to rationalize the denominator. But here, it seems like they want the decimal value. Meaning, you can just put that into the calculator, get a decimal value, which is 112.6 feet. Some of you might say, well, could you have done using calculator from here? Yes, you could. You could have done just carry on tangent 60 degree all the way, and you can just tap into the calculator, get the answer as a decimal as well. Okay, so you should try this question by yourself and this question by yourself. And this was one example from the Alex. It's exactly same as what we've been doing. You will have to use trigonometry to find the one length. Then you can use Pythagorean theorem to find the other length. So you should try that. That was one of the problem on the Alex assignment. So after this, you should try Alex assignment, learning assignment number 3. Okay, I'll see you for next lesson.